Hi, so this is Sara Abu Hasna for class CSC 578 at DePaul Neural Networks. This code that you see is a code taken from the NNDL book. It's an algorithm used to implement stochastic gradient descent learning for a feedforward neural network. So this is a pre-written code, and we added some modifications to it. Specifically, we wanted to return the mean squared error and also the entropy and the log likelihood from the evaluate function. So let me get straight to it. So as you can see, I added a y list, an empty list, and an entropy and an MSE variable equal to 0. The reason for that is because we iterated through the test data, and for each x, y value in the test data, we appended the y value to the y list, and we did the activation for each x using the feedforward function. We equated it to a, and so we computed the mean squared error function for each a and y, and we summed it up to the variable MSE. So each time it would add it to itself. And for the same concept for the entropy, and the way we did that was we did a numpy minus y times the ln of a minus 1 minus a times the ln of 1 minus a. These functions were taken from the NNDL book. For the log likelihood, it was not in the loop, for the reason that it's the minus ln of the a with the maximum y index, which is the reason why we created a list, because we used np.argmax, which is a function to obtain the index of the maximum y in the list. And then we did the minus np.log, which is the ln of a, the a for in which corresponds to the maximum y. Because it returns a vector, we did the index of 0, which gives us a 1 value rather than a vector. We then returned the accuracy, and this is the equation for an accuracy, which is the sum of each x equal to y in test results, and we also returned the mean squared error, entropy, log likelihood as index. So this was used in the SDG function, where we did print, and this is the format of the print, the epoch, the training, the cross entropy, log likelihood, and the accuracy. So we did self-evaluate, the return of the evaluate function. We indexed for each item it returned. So we did the same for the training and for the testing, same format. And then we also, we wanted to return the train list and the test list result from the SGD, and so we created 2 empty lists, and then after each epoch we would append to the train list and to the test list. And then we wanted to also break after the accuracy was greater than or equal to the self term percent, and hence this was the code for it, which is if accuracy is larger than the term percent, we break out of the loop. And this is the application code. As you can see here, we're going to run it, and we're importing the file. And then as you can see here, you can see the activation, the activation arrays, and this is the result, and it does match the result that was given as an example. And then we wanted to see the 2 lists, so we returned so it prints out the 2 lists once we do result 2, print result 1, print 2. It prints the training list and the test list, and then we imported the iris data so we can test on the iris data, and we loaded the network and changed the term percent to 0.6, epoch of 100, and mini batch of size 20, and these are the results that we obtained, which do also match the example for 10% 0.6, and we also the same for 0.8. We then added a network with layers of 4, 27, 3. We changed the network and re-ran it with the same samples of sample 1, sample 2, and we did also get the same results as the example result that was given. And then we also ran it with 10% of 0.6 and 0.8. Thank you so much.